G'day everyone, today's data recovery job is a Emtec 16 gig USB stick, and this one was plugged into the side of the laptop and a door swung out and has hit it. And if I show you on the meter, we're drawing 0 amps. That is an open circuit. So this USB stick is using a Phison controller, the PS2251-68-5. Phison makes controller chips for anything that's got solid state memory. So you'll see them in memory cards, USB sticks, SSD drives. So there's the reason for the mechanical movement. It's broken this little mounting soldered pin there. So the solder's okay, but it's cracked. It's been strong enough to crack right through. So I've just put a little female connector on this USB so I can test the continuity with all 4 pins. So if I've got the multimeter in continuity mode, I can test that the connection follows all the way through to this pin, which it does. Then I'll go to the next one, which it does. So does that one. Okay, so there's a good connection between all 4. The next thing I'm going to do is check the voltage. So I've got the little amp meter again. You can definitely see 0 amps. There is no current flowing into this. Let's see with the multimeter in voltage mode whether or not we can measure any voltage. So I'm going to pick a common ground for the negative, just the USB connector. And let's go straight in. So we've got 5 volts coming in. No problem at all. We're going to follow that, which goes down to here. Looks like the back of this capacitor as well. So we've got 5 volts to the back of this capacitor. And we've got, yes, we do get 5 volts here to this resistor. What does the other side of this resistor show? Alright. Try and get a better touch of that. Five volts. 5 volts in, 5 volts out. We've got 5 volts to this capacitor. Okay. Let's just touch around and see what else we find. Okay, 3 volts. So we've got 3 volt logic, 5 volts on this capacitor here. There's an LED which should be flashing and lighting up. So we've definitely got current flowing into this. We'll have to have a look on the other side. Now on the other side we've got our controller, so I'm assuming this little circle here is our pin 1. So if we probe it, we're getting 3 volts, which I think should be good. Probably a little bit under, but it should still operate at the minimum level, and I just shorted that. Okay, 3 volts there. 3 volts there. We got 1 volt. So these 2 capacitors here might be responsible for some of the NAND power. So we've got 3 volts. 3 volts. Okay. So it looks like we got 3 volts going into the NAND as well. Okay, interesting. Let's check our electronics. Make sure there's no shorts to ground. So these ones aren't on ground at all. Oh, you know why? Because I'm using something that's cracked. So we should be using our negative pin. Okay, that's good. That's good. So we should only be getting a beep on one side, which is the ground side. If we get a beep on the other side, it means that that side is probably shorted to ground. That's good. Okay, there's nothing else. There's no obvious short to the ground. Look, I might resolder this in anyway, just in case it does play a role. You never know. So we've got a open circuit problem. That means something is not connecting and it's not using any electricity to run. So I'm wondering if there's something cracked underneath here that I can't see, maybe torn a line that's just not feeding the controller. Our 5 volts goes in here. This resistor must be responsible for feeding in somewhere. The only other thing is that if there's been enough force to crack this right off, then that force can crack any of these little pins. Get in with a bit of isopropyl. You can see that this chip has been painted over. It's even cleaning the black. What's under that? Don't know why they paint them. Usually I've seen them painted where they try to hide it under like a clear plastic case. Yeah, the painting thing's weird. If anyone knows, write me a comment. 1C 16 gigabytes doesn't mean much. Must be just some in-house code. So we'll get some flux on everything. I'm just going to run heat into all these solder joints just so the solder can melt, reform, and possibly fix any connection issues. We'll do this side of the chip too. And it looks like it's working. It goes nice and wet, nice and shiny. We'll do the top. And I'll let that cool down slowly. There you go, you can see it start to cool down and it goes dull. So that'll fix any cracks that's probably occurred in the solder, if any. There's only one reference to this memory online, DT57G2GAHC, and someone says it's 24 nanometers and it's MLC, which is 2 bits per cell, which is actually good memory. They don't make them like they used to. Let's plug it back in. See if that soldering did anything. Nope, still got an open circuit. I'm going to remove this connector. I want to have a look what's happening underneath. So we've got some solder wick to suck up all the solder from the joints that I want to remove from. So one at a time I will separate the pins. And we're off. Okay guys, does this help us? Let's get in a little bit closer here. First thing I'm going to check is this pad's lifted here. This is the 5 volt in, so that's not connected to anything at the top, and that's still mechanically connected to where it should be. The ground is literally just one big ground plane. So there's a pad there, but practically this whole area is ground. That looks okay. I think we can see our problem. I'm going to take it out so I can zoom in and show you guys better with the focus. Now, zoom in to the data pins. How's that? Okay, we've found it. Okay, I think it's what's happened is one of our USB data lines is ruptured here. Yes, it is. Look at that. If I lift that up, so that means it's not communicating with the PC and it won't turn the controller on. There's our problem. Hidden underneath. So if I can carefully cut back this top layer of the PCB and expose this little hole, this little via hole, if I resolder this, it should work. So if you have a look, what's happened is we've checked all the power lines. They're all working fine. The chip's getting power, but it's not being turned on because the data line isn't getting any signal. So why would it just sit there wasting power? Unless there's some kind of signal from the data line of the USB port, it won't turn this circuit on. So that explains our open circuit for this one. And it's a bit hard to see, but these little holes here, these little via holes, connect the bottom side of the PCB to the top, so they'll come out underneath this chip somewhere. And I'm just going to dab a little bit in there. Now I did remove all the solder from these little pads, so we'll have to top up the solder and I'm confident I'll even use the same connector that was on it. So let's just ball up some more solder. Try and sit it up or something on an angle so I can see underneath. Okay. So I'm going to solder the outside ones for mechanical stability first. And then I'm going to get my tweezers. Hold these data pins in. We'll do the ones, that one. And we're going to keep an eye up in there. Make sure that that doesn't come apart. So, okay, nice and quick. What do you think? Do you think we got it? What do you reckon? Let's try this. Will it work? We're looking for an LED to fire up. Huh? Nothing. God damn it. Is it possible that this little soldering connection didn't work well? So I'm going to see which pin this connects to, and I'm going to assume it's on the top somewhere. Okay, in here. That's our pin. So I think I've made a mistake here. The one I scratched is this pin, and it's okay. This one is not. For this one I'm going to change my soldering tip from a wedge, which is the best, to a little point. Dab on those haters. Okay, and let's see if this little tip has a better chance of getting in there. It already is smaller. Look at that! Oh my god! Is it detecting? It stopped blinking. I'm gonna try and solder that again. No, we've lost it. We've lost the LED. Okay, I got an error message up. USB device not recognized. So it must be getting close, unless I killed it. So that's definitely soldered to that little via hole now. So I'm not sure if we're getting a connection. I'm going to see if we can trace out which pin it is on the controller chip. Yes. So we're going 1 step forward and 2 steps backwards. I'm going to solder some wire to this now. Got it. Okay, I've got the multimeter connected. Let's find this pin. Very good. It's the one next to the one we marked earlier. So can I improve my markings? I'll do that there. And maybe I'll come back a bit more so I know it's the one underneath. So you got that one and this one. And I think while we're here, we'll put a wire on this one as well. Or do we need to? What is the easiest? We haven't had it very easy for this one today. Yeah. A bit too much solder there. Don't want to get jujitsu'd again. Okay, that looks alright. Now, if you have a look at these wires, I've got them soldered. And the length goes to about here. I've deliberately got this one coming up next to it because this is a differential pair. So I need to cut them the same length so that we keep the same impedance. Because one signal goes, when one wire goes high, the other one does the opposite. So now we've got to figure out how to connect this connector on again. I think I'm going to do 2 pins down for power. And I might come over the top for these data pins, so we might bend them up. Okay, that feels reasonably strong. Okay, so the top one should marry up to the top pin. We need to find a cool style and design. So if we come around here, okay, to do the same, but to here. Wow, that looks cool, but will it work? Okay, it may look weird, but as long as it works, we should be fine. I'm happy. I don't care what it looks like. Oh my god, do you guys see that? Wrong way. It's just popped up. Okay guys, we have access to this USB stick. The little LED's flashing. I can't believe it. That took way longer than it should have, but at least we got there. And at least we're going to give some data back to this owner. And check that side out, guys. Beautiful little LED flashing. It is working. It's running. I've got to get a lot of data off it.